All right, so these are going to be function operations. So this is section 7.6. Function operations. So when I say operations, we'll go with the easiest operations of functions, which would be add, subtract, multiply, and divide. Okay, those are easy. When I say functions, let's see if you can remember what a function is or what function notation looks like. So if I have something like f parentheses x, I say f of x equals, we're going to do this one as 10x. And if I said to find my function f at 2, that would mean to substitute for every x in the function a 2. So f of 2 is 10 times 2 is 20. It's for function notation. Oh, because we're going to have some shortcuts where we're going to be using the f and not going to be, and so it is a kind of a shortcut notation for things. Okay. That's no, a shortcut notation for y that's longer than y, because basically it's okay. I'm gonna have to add and subtract functions. So let me get another letter. You can use any letter of the alphabet you want for function notations. So G is the next letter in the alphabet, so that is the one I will use. So let's call G of x. I'm going to give it a value of 1 plus 7x. So if you graph these, you'd graph them just like y equals 10x, y equals 1 plus 7x. You just get that little shortcut of being able to substitute in a 2 or a 10 or whatever. Okay? So first thing I'm going to do with these functions f of x and g of x, and remember what they are because we're going to use them we're going to use them 4 times. First thing I'm going to do is add these functions. So you can write them as f of x plus g of x, or you can see them written as f plus g, usually in parentheses, of x. This notation means to take f of x, oh that's 10x, and add it to g of x, that's 1 plus 7x. Oh, so what is 10x plus 1 plus 7x? 17x plus 1. Combine like terms, simplify where possible. Okay. You can subtract. So we could take f of x and subtract the function g of x, also written as f minus g in parentheses, with the x in parentheses. These two ways of writing this would read exactly the same. And so if I wanted to take f of x and subtract g of x, f of x was 10x. Subtract g of x, 1 plus 7x. I better put that all in parentheses because I'm doing a subtraction and I want to distribute that subtraction sign. So f of x minus g of x would be 10x minus 1 minus 7x, better known as 3x minus 1. Okay? Addition and subtraction. Now we get to multiply. Woohoo! You are so right. Those are just two different ways of writing the same thing that you will see it written in two different ways. When you subtract them, sometimes you'll see it as f of x minus g of x, and sometimes you'll see it as f minus g of x. They mean the same thing. The question can get asked either way. Okay, so f of x times g of x with a small dot can also be written as f times g of x. So let's multiply them. We still had 10x times g was 1 minus 7x. 1 plus 7x, thank you. So now I'll just distribute 10x times 1 is 10x plus 10x times 7x is 70x squared. So there they are multiplied. And the last thing we'll do is divide. So I'm going to take f of x and divide it by g of x, or write it as f divided by g of x. So f of x is 10x, g of x is 1 plus 7x. I don't simplify that anymore. That's plenty simplified for me. We have one little issue going on with division, and that's called that we never divide by a negative number. We never divide by negative. We never divide by 0. Okay, so I don't want x to be some number that's going to make the denominator 0. So 1 plus 7x can never be equal to 0. So that means x can never be equal to, let's work this out. 7x can't be equal to negative 1. X cannot be equal to negative 1/7. So that is called a restriction in my domain, because x's are what my domain is, my inputs. So when I'm asked about the domain of this new function, well, my domain can be anything, any real number. So I can write this out, any real number except negative 1/7. Another way that you can shortcut writing out that domain is you could say the domain is x is a set of all real numbers, and we often don't write the set notation, except, yeah. You can write it like that too, in words, in symbols. Yeah, you can use the greater or the less than thing. All right, so that's only going to affect me when I divide by 0, or if I take the square root of a negative number. So my multiplications, my domain, is always going to be all real numbers. The way I abbreviate all real numbers is that funny looking R. For my subtractions, my domain is all real numbers. For my additions, my domain is all real numbers. And I only get into trouble if I'm looking at dividing by 0. So that only happened in my examples when I did the division. Yeah, it's all, yeah, essentially. No. Do you ever have to solve it? No. They'll ask you to multiply, and then they'll say, what's the domain, and what's the domain? And so you multiply, get the answer, and you state the domain as all real numbers. What's the form called? Well, we're just doing operations with functions, and then once we get the operation completed, we sometimes have to say whether there are any numbers that we can't use. So that's where we have to state the domain and range. Okay? Yes. And final, yeah. Oh, there's more. Now I get to